everyone. It's good to be here at Agile on the Beach, my 6th year, second time speaking. It's colder than previous years. First time I actually had to wear something over my t-shirt. So today I'm going to be talking about how we can get better at explaining counter-intuitive ideas in software delivery. And I hope by the end of this talk, I'll get better at pronouncing counterintuitive. But it's a bit of a tongue twister. My name is Hibri. I help teams deliver software fast, and I want them to enjoy doing so and be happy. I'm a principal engineer at ClearBank. I help build the platform so that the devs can do all of that. My feedback code is right there, so if you want to take a picture of that or scan it, I'll put one up at the end as well. So, software delivery is hard. It's really complex. That's why we're here. It's hard enough that it justifies 2 days and a track dedicated to it, right? If it was easy, we won't be here, we would be out there actually doing it. It's hard because it's not just copying files from one computer to another. You need to make decisions. Like which file goes to that computer? Is a file good enough? We need to trust the things like Jenkins, the things that do the CI/CD, that they do the job properly, right? If that breaks, like people shout at the platform team or the team that looks after the delivery. There's so many moving parts to make it work. Like when I look at this, like, I'm not sure if the CNCF landscape, I can't tell the difference at this point. Like putting all of these tools into a software delivery, like it's just mind-blowing. I find it hard to deal with, increases our cognitive load. And it's just not the tooling, right? If it was just a tooling problem, we would have solved it a long time ago with Jenkins and cruise control. We now have to keep building new things like Argo CD, and I don't know what's the latest right now thing with ChatGPT and AI. So yeah, how we organize ourselves influences our ways of software delivery. And on top of that, you got to keep up with all these tools. You got imposter syndrome, fear of things breaking. Like, the platform team does deal with a lot of things, emotions. Like when things break, they got to fix it. Lots of people shout at them. And yeah, got to. Oh, by the way, you also have to read the whole Accelerate book to get everything right. So yeah, it's all very complex, right? And on top of it, you have to navigate all the organization silos. Like, just people get siloed very easily. I've seen, like, even when teams are self-empowered, they seem to be self-empowered to get siloed. So it's hard navigating all of this. And most of us got into this so that we can build cool things and show our users. I got into coding by building screensavers. Like you could build a screensaver, show it to someone, like, oh, look, the ball bounces up and down. So life was simple back then before CI/CD. Is it a wicked problem? So these two guys, Horst Rittel and Melvin Weber, class problems as wicked and tame problems, right? So they say wicked problems are ill-defined. They have strong moral and political professional issues. They're highly stakeholder dependent. Sound familiar? There's often little consensus about what the problem is, like what are we actually trying to fix. These problems don't keep still. Once you solve them, they just don't go away. They just evolve into another kind of a monster. They're complex. They interact in a dynamic social context. And if you solve it, oh, there's a new problem to solve. And they're often a symptom of a problem somewhere else. So how is software delivery a wicked problem? So if you look within your organization, everyone's probably got a view of how it should work. It's hard to get consensus. The ops team look at it in one way, the testers look at it in another way. You can't also see it as like binary, like, it's not good or bad. How much test coverage is good? 100%? 30%? It depends. There are no one-off solutions like, once you built your first pipeline, your platform, is it done? No. Just have to keep on evolving, managing it. And you can't take what worked in one organizational context and put it into the current context. I've fallen into that trap. You can't just, the Spotify model doesn't work anywhere else. And then, yeah, it's a symptom of another problem, like, how your HR department set the salary bands and how the pipeline, their hiring pipeline works has an impact on your software delivery pipeline. If you don't get skilled people, you can't build all of this. So to solve wicked problems, we need to change people's behavior. It involves breaking down silos by changing the relationships between individuals and teams and in between teams. Yeah, it involves change the nature of the relationships, not just the relationships like, do people just naturally talk to each other, or are they just sending tickets over the wall? Is it like antagonistic? Is the other team a subcontractor of another consultancy? They've got different rules. You got to see different perspectives. Testers have different perspective. Ops people have different perspective. And it's not like that anyone is wrong. All those perspectives are valid, and then, you have to see the whole, get everyone's perspective, solve wicked problems. So, we have solutions to these problems. And they are wrapped in these like heuristics and mantras that we keep repeating. If it hurts, do it more often. Slack time improves flow. Releasing more often improves quality. And a lot of us who've been in industry long enough, like, we know how these things work intuitively, right? But it's hard to explain these things to non-technical stakeholders, people who are coming new to the industry. But also, in a dynamic, complex system, things change rapidly. And you suddenly see that, these heuristics just stop working. If we don't understand what goes behind them, it'll be hard to manage the wicked problem. So today I'm going to pick one of these, and we're going to see how to explain the concept and what's behind it. And I'm also going to break all the visual communication rules from the previous talk. So, yeah, last year I was listening to a podcast, and Nicole Postgren from Accelerate and Dora Frame said, the simplest thing you can do to improve quality is to deploy more frequently. Now, that's counterintuitive. Yeah, how does it work? If I tell it to a non-technical stakeholder, like, why would you deploy something that's broken more frequently? Shouldn't we test it till the end of the universe to make sure it doesn't have any more bugs? Right? If you know it has bugs, why would you do it more frequently? Yeah, that's counterintuitive. So, in software delivery, we talk a lot about feedback loops. Software delivery is all about mastering your feedback loops. We know this, but how often do we actually model them? How often do you actually draw them and see, oh, how is this thing connect to the next thing, and how does it all hold together? So we need better models to understand and explain these ideas. And when I try to explain things, I end up looking like this. So hopefully it won't happen today, but I'll try my best. So if there was one thing you take out of this session is how to model your software delivery system and sort of any system you're working with. We are really good at modeling the thing we're building, but we are not good at modeling how we build the thing. We're like, we do user journey, story maps for the thing we are building, but how about the story maps and user journeys for, hey, how do you have our retrospectives, or how does the team work? So yeah, that's also important to model. So let's get started. We're gonna tell a story by visualizing feedback loops. I'm going to use causal loop diagrams, and I'll explain what they are in a bit. Important bit, I'm going to tell this from my perspective, and I'm going to draw a generic model. The model you draw would be different. So obligatory George box quote, all models are wrong and some models are useful. So don't take my model and brand it Hibri's model, just like Spotify model, and implement it elsewhere. Cool. So why do we use causal loop diagrams? Causal loop diagrams have three basic elements. A box, a connection line, and a feedback loop. The connection line indicates the direction of influence. So here, A influences B. Don't worry about the quantity. They don't need to, you don't need to make sure they are of the same metric. It's more about the influence. So here A influences B, and then B influences A. The line indicates the nature of the relationship. So I've got a plus sign there. So an increase in A increases B. Well, if B increases, A increases. So that closes your loop. You can also have an inverse relationship. So reduction in A could increase B, and so on. The causal loop diagrams are one of the easiest ways to get into systems thinking. They're very intuitive. There are other models, other mapping techniques like Wardley mapping, rich pictures, stocks and flow diagrams. What's important is that each of those mapping modeling techniques gives a different perspective on your system. So it's always good to use multiple modeling mapping techniques to see different sides of your system. But we'll keep this simple today. So where do we start? We start with one variable. So because we're talking about software delivery, this is where our problem starts, getting something released. If we didn't give anything to our users, we don't have anything to worry about. So we start with the size of release. Why do you pick the size of a release? You could have these discussions with the people you're building the model with. In a release, there are a number of changes. Some of these changes will work in production. Some of these changes won't work in production. And we won't know what happens until we actually release it to production. So then we look at what that variable contributes to and other things that can contribute to it. Right? So in this instance, like the size of release increases the number of failed changes in a release, the probability of failed changes in a release. Another way of looking at it is like, you get a box of chocolates. You like some flavors. I don't like the tangy ones. I give them to my wife. Raspberry, can't get on board with raspberry flavors. So the bigger the box of chocolates, the more likely the flavors that you don't like. So all we try to do in our software delivery lifecycle is to reduce the probability of the things that we don't like, your bugs, things that could blow up production. So let's see, where are we? Yeah, so when there are failed changes in a release, we're not talking about the successful changes. Something breaks, increases change failure rate. So we've established a simple relationship, like an increase in the size of the release increases the likelihood of failed changes in a release, therefore increases your change failure rate, right? So that's a simple kind of model, but we haven't closed the loop yet. So we need to go a bit further. Right, what happens when things break? Yes. And what do you need to fix it?
Time.
Very good. Yeah, while things are broken, you need to roll back. That also takes time. And or you need to roll forward by fixing the bugs and doing a new release. It all takes time, right? And this time is toil. It's time not spent building valuable things like new features. So in lean terms, it's waste. So the less time we spend fixing broken release, the better it is. So while we are fixing a broken release, what's happening? We're adding a delay to the next release. There's no way I can figure out how to get two releases to exist on the same server at the same time. If you could figure out a Schrodinger's production environment, it might work. So while we are fixing the current release and taking more time, what are the devs doing? Yeah, they're still coding. They're still typing, right? The double lines on the arrow indicate like a delayed response in causal loop diagrams, like something that's going to happen later down the line. It's not immediate. Yeah, the devs are still adding new things. They're still in their sprint. The release is broken, but they're still adding new features to their sprint. What happens then? The size of your next release has just gotten a lot bigger. What happens when a release gets bigger? More chocolates that I don't like, right? So the longer we spend fixing a release, the bigger that box gets, and it increases your probability of failed changes in the future release. So we're always thinking about the current release, like let's fix it, let's get it out, but no one's told the devs to stop typing. So by using a causal loop model, let me just kind of go back to that. We built a simple model. We've closed the loop. We've established a relationship with the current release and how it impacts the future release. This is our system engine. We can see now how our software delivery system works. And all these variables, they are the core variables that we have to deal with in our software delivery system, right? So now we can identify patterns, right? The first pattern is the reinforcing loop. I call this R1. So if you have a more complex diagram, you'll see a lot more loops. So the pattern here is why is it a reinforcing loop? So each variable increases the next one, and then it just gets bigger and bigger and bigger and bigger. It doesn't get worse over time. Till something else happens and everything either blows up or there's other intervening factors that try to moderate the system. It also shows things that are in our control and the things that happen as a result of our actions. We can't control the change failure rate. That's influenced by size of a release. We could put an arbitrary limit on the time to restore service, but that depends on each incident. You can't say, I fix it in 2 minutes. Oh, what happens if you don't fix it in 2 minutes? We can't control this. We can control the number of new changes. Yeah, so it shows like where we can control the system. And so what we're doing here is like we're seeing the system as is. We haven't changed anything yet. I haven't gone off and said, hey, you know, throw away Jenkins and use Argo CD. I haven't intervened. I'm accepting the system as is. And when you do this, it's important to like test your model with a few recent releases. Just make sure like, you know, your model matches reality. If not, you know, add new variables, change the relationship. So it's important to look, tell the story of what's actually happening. So, you know, even though this works, don't take this and use it on Monday. So things are getting worse. There's a vicious cycle. Not all reinforcing loops are vicious cycle. It depends on what's happening. So, you know, obviously we have to change things, right? We can't accept the system as is. So, to break the cycle, we need to reduce the influence of one thing on the next. So we have to like pick the things. Like as soon as like we started reducing the size of release, oh, that will reduce the number of failed changes in release, and then that starts making the cycle less vicious. So let's start with a couple of like obvious interventions that, you know, we see, right? The first thing is like, you know, pretty obvious. Let's take more time to test everything before it's released, right? Again, what's that doing? You know, what happens when you take more time to test a release? Yes, you find more bugs, but that's also, yeah, it's completely valid. You will find bugs, and then that reduces the number of failed changes released. So you're reducing that. Then, yes. So while the testers are testing, what are the devs doing? They're still typing, right? So we haven't really reduced the delay to the next release. And it temporarily fixes the problem. It's a Band-Aid, but you haven't changed the system. So if you have a culture of continuous flow, like if the devs are like stop the line, let's go fix everything, this works. So now we see the relationship between culture problem. The culture problem is reflected in your causal loop diagram. Right? Next thing, every December, just like a Christmas party, release freeze. What happens when you do a release freeze? Yeah. Yeah. So yeah, the longer the release freeze, the longer the delay to the next release is. So release freeze work only if you send the developers on holiday, or you send them on training, or do something else, and you know have a complete code freeze. Like if you have release freeze and the devs are still typing, just tell the devs to go home. Everything would be easy. Yeah, they just increase the batch size of the next release. So, yeah, but you know that's a cultural problem to solve. Let's look at other things that add to delays between releases. Let's take manual deployments, right? Manual deployments, yeah, they're okay. Okay, they work when they work, but when things don't work, they make things really bad. Like if you have a bad release and you're trying to do a manual deployment on top of it, it's like just ends up making things even more worse. It reduces toil, errors. Oh, now you got to deal with bugs in your release and errors in your manual deployment. Yeah, let's say end-to-end testing take more time, even if it's automated. When you do end-to-end testing, there's more fragility. It takes more time to find the fragile test. Let's fix it. Still more time, but yeah, the devs are still typing. So we looked at common interventions. They don't create lasting change. Taking more time to test things just makes things worse. So how do you make lasting change? Let's go look at an iceberg. So Donald Meadows describes where to intervene in a system using the iceberg model. So in our causal loop diagrams, what we see are events, like the visible part of it. That's the stuff above the waterline. An iceberg has more things that we can't see below the waterline. Modeling a system using causal loop diagrams helps us see what's below the waterline. So let's walk our model through, from top to bottom. So events. Events tell us what just happened. Right? Hey, come in the morning, a release is broken, there are bugs. We can walk through recent release and see what events happen. Like, what's the reality? Like, this is stuff above the waterline that we see. So, and again, the model you draw will be different. But events are just the visible part of patterns of behavior. Once you add a time element and see events across a time dimension, you see patterns of behavior. How is one event connected to the other? So this is in a recent system I worked in, like after every sprint, custom issues, they go up. And after a couple of days, they die down. And then like clockwork, after every sprint release, they're doing a lot of manual testing. So we saw that pattern. So this we saw this in the Jira customer support cases in these graphs. So that's you see those patterns of emerging. So it helps us understand what will happen, what has happened before, by just connecting events over time. So patterns of behavior are influenced by the structure of the system. How is one event connected to the other? That's your system. So by modeling, we've seen this is your system. How the size of a release contributes to the number of failed changes in a release. So this reflects your software delivery system. It doesn't matter what technologies, how you're organized, which team does it, right? All that matters is you got changes, they need to go to production, something will break, takes time to restore service. You could discard all of that stuff away, architecture diagrams, away, because this is the behavior of the system. And the structure of the system is influenced by the mental models of people in the system, right? Because it's how we react to these events that defines what's the next event. So causal loop diagramming and system diagramming helps us see and visualize the mental models that drive the system. So in our example, we see that the mental model of optimizing developer productivity causes the overall system to suffer. And we can see that, if we have the other mental model of, if a team owned the end-to-end delivery, you get a different behavior of the system. And now we can, we know where the leverage points are. We can test our interventions. we can ask questions from our model. Okay, what if we introduce WIP limits? What's the impact on the system? So, if you put WIP limits, that puts a limit on the number of new changes. So that doesn't keep on increasing. So that now you're starting to reduce the number of new changes. That then starts to reduce this. And then things start getting better. So it's about like finding like how finding the intervention that reduces the impact of these variables, and then that influences something else. So if we didn't connect one thing to another, we wouldn't be able to see what's the impact of our intervention. So that's any change you do anywhere else doesn't change the system. So that's where you get the highest leverage to improve your software delivery lifecycle. So always WIP limits are my go-to like tool. Like want to improve something, put WIP limits in. More on asking questions, like you could ask questions about incentives. Like I've worked in places where developers' bonuses were tied to how many stories they finish in a sprint. So that's an incentive that drives a number of new changes. So you're now going to the cultural things, not just the technical stuff. And if you have everyone has a mental model of start, finishing, stop, starting, that works towards WIP limits. So we now have a better understanding of what drives our system, and why deploying more frequently improves software quality, right? Deploying more frequently reduces the delay to the next release, reducing the number of new changes, reducing the size of a future release. That again reduces the number of failed changes in a release, and so on. So we see how things are connected. What's even more powerful, it's fine for me to do this by myself, but if we do this collaboratively, we bring everyone else's mental models out. Right? Everyone has a different mental model in their head, and this is one of the things that causes wicked problems. Like we hold different mental models in the head, and there is conflict. We have different ideas, different perspectives. So by modeling collaboratively, we're able to resolve those conflicts. And collaborative modeling, by seeing the diff between people's different mental models, gives us more leverage in the system, because now we know what people are thinking. So counterintuitive ideas or mental model shape our system. They shape the system structure, the patterns of behavior, and finally, what's actually happening. So this is all in our head. So this is why it's really important. It's how do these things work? Because we might solve the problem, but if I kind of go back to my model, anything could change here to make the system go back to its previous state, right? So, and again, we can also see how different mental models make different kind of events happen. Releasing once a month keeps us safe. You can test the impact of all of that. So it's if someone in management says let's go back to our old ways, this releasing frequently thing is too risky, we can go back to a model and say okay, this is what happens if we go back to these behaviors. We can start experimenting with the impact. So this leads us to non-linear strategy, because wicked problems, solutions to wicked problems, don't fit neatly in a Gantt chart. We can expand our model and see so it's pretty rare that you'd come up with something clean that's self-contained within your own team, right? Our software delivery system doesn't exist in isolation, and accelerate the Accelerate book does a good job of explaining all the different factors that impact our software delivery performance. Like, is there a learning culture in the organization? That impacts, can people learn automated deployment? Is there funding for new courses? Is there funding for a new skill? Is there slack time to invest in new learning? Attitudes to collaboration. Are people ticket-driven, or is there psychological safety that, if there's something wrong, that we can go and talk to someone and get it fixed? So, all of these things have an impact on your system. But you can expand, but up to a point. You need to draw boundaries. Like, I can't bring my home life into this. I still have to keep things in focus. Yeah, so you can expand up to a point. And when we started on this journey, you'll see that we accept the system as is. Like, the system has a certain wisdom. So that's why it's important to model the system as it is before jumping in to change things. It allows us to observe, ask questions. Most importantly, like, the system exists because it works, right? We've all worked with big banks and large enterprises. Like, we think like, this shouldn't work. Everything should collapse. This is really awful. It's dysfunctional, but they survive because the system works. And sometimes the system pushes back. So if we go off and change things without understanding the system, we can't make meaningful change. So it's important to understand why things work as they are by modeling with systems thinking, and find the real leverage points that will give you lasting change. Yeah, and strategy isn't static. You got your model, you can tweak things, you can see the impact of things, you can add things to it as time goes on. So it helps us coexist with a complex dynamic system. Yeah, so we have to understand the dynamics. It's just, things are not static, things are moving. And in our modeling, we should figure out a way to model that movement over time. And iterating, continuously improving our models collaboratively, which means more people get involved itself is a better strategy, because now by modeling collaboratively, you influence their mental models. So that could be like your simplest strategy to deal with a problem. So it's just model things together. Love this quote from Diana's book. Models are conversations. Like, the model I showed is a conversation with myself. But if you talk to someone else in your team, in your company, you'll get a different model. So it's important to establish healthy and impactful modeling process. It doesn't matter which tool you use. Yeah, and because everything's really complex, we've got to figure out how to dance with the system. Like, we can't just, a lot of us here are consultants. We go in thinking like, oh, look, I can pull strings here and there and change things. But after a while, we burn out, get frustrated. Like, I'm not going to work for this client anymore. Yeah, so we have to learn to coexist. And before I end, I'll leave you with a Dirk Gently quote. Who's heard of Dirk Gently? The holistic detective, yeah. He has a holistic approach. He just waits for things to happen and just believes in the fundamental interconnected of things, like what his cat had for breakfast has an impact on the murder investigation he's doing right now. So yeah. So before I end, I always like giving book recommendations. I did start reading Thinking Systems at first, but it didn't make sense to me at all. There's a really good Open University 8-week course. If you're in the UK, it's free. teaches you all about causal loop diagramming, systems thinking. It's free. And then I read The Grammar of Systems. This is by Patrick Hostad. It's really, really, really good. Helps you like make sense of all the different systems thinking archetypes, patterns you'll see. And then, O'Reilly, Learning Systems Thinking. And these two books kind of very, very deep, but I keep coming back to this. So thank you. And before I go to, questions and my feedback. Thank you. Hope that made sense. Yeah. Yeah.
I have a question.
Yeah. Well, okay. I'll pull this up.
Is there a mic there? I had the best fucking time. That was excellent. Thank you.
Thank you.
I'm very fallible. So I've been really black and white, and I will be like, okay, I'm so sure that this will lead to this, and then I'll be really surprised. Like that wasn't what it was at all.
Yeah.
We just have to accept that we have to
Yeah.
the model once we learn more. Or...
Yeah. You have to always change your model as you learn more, because like again, just like your system, no model is going to stay static. Yeah. So it's important, like for this to reflect reality, so it can actually tell a story, like to real events. These aren't just abstract things. We should be able to tie these to this is just a starting point of a huge topic called system dynamics. Like there are complex modeling techniques where they feed these variables into computers and model the thing. Donald Meadows contributed a book called Limits to Growth, where they model the economy of the planet, and it's like the prediction they did 30 years ago are true. So these are variables, like we can measure things. We do tend to measure things in isolation, but we don't connect the measurements into a much more dynamic model. That's kind of like the next stage of causal loop modeling and system dynamics, like getting data and putting them in graphs, seeing the patterns over time. Yeah, it has to match reality.
Can I ask another question?
Yeah, anyone else? Anyone else? Yeah.
When you're mapping a team and their behaviors like this, can you tell the team that you're doing this?
It depends on psychological safety. Like this is kind of the dilemma. If you go to team and say like, oh, I'm going to do systems thinking, and then you kind of have lost them. Just focus on telling stories. Like I've used just simple post-it notes to go through through a blameless postmortem. Okay, this thing happened, and then this thing happened after that. No drama. And then later on, I can change that into causal loop model and iterate. It's just, sometimes, this took me several goes. Like, you're questioning, are these things right? Are the words right? You kind of have to get all of that correct.
Does the team know that behavior has changed?
If they see it, if they see the impact of their behavior, then you're going to their aha moment. It's like, oh, the change comes from them because they see things instead of me telling them, like, this is the thing you have to do. Because, we end up in silos. Usually a software delivery system is spread across many silos. Like everyone's trying to do their best job, right? What this modeling does is like it removes the blame from the silo and the individual to like, let's just focus on the events. Like, let's just see what happens. You blame the system, not the individual. So this is a system that we can blame. Yeah.
Have you found? So can you tell us about an assumption that you made that was wrong in the past? That you were like, oh, I thought it was this that was influencing this, but like, or
Yeah. So when No, actually, I can't remember. Sorry.
No, that's
I did make some assumptions when I was doing this, but as I was trying to connect it, it's like, oh, that doesn't make sense. I have to change. I have to change that. I published a blog post on it. Like, this model is different from the diagrams I have in my blog post, and also how I add the plus or minus signs. Like, I'm also telling a story, so I have to like figure out like, is this really clear? I'm pretty sure, you know, someone else, you know, if I work with someone else in here, we'll be able to come up with a better model. Yeah, and by doing that, like, it challenges my own assumptions.
Thank
Yeah.
you.
Thank you. Yeah.
That was great. Do you think you could build one of these for what was on in your house?
Yeah, like, can, like, you know, family is a system. Yeah. Like, I like don't, you know, my 2-year-old has a tantrum. Like, I think about like, oh, how do I react to the tantrum? Do I match the anger, or do I stay calm? The more, if I'm angry, she gets angry, and then we get stuck in that vicious cycle. So it's like, oh, how do I break the cycle? I've read that there are therapists that use this. Yeah. Oh, thank you. Hope you enjoyed that.